Hello there, thanks for watching and I appreciate you. This is a video in a series of videos showing you how to make a custom character controller that uses Rigidbody physics, cinemachine cameras, Unity's new input system, and custom player gravity. In the last video, we implemented a seemingly decent method for our character to traverse slopes smoothly and at a constant rate. We then made it so our character goes up slopes slowly and down slopes more quickly. We added a maximum slope angle limit that our character can climb, and at the end of the video I made note of a few issues with it. In this video, we're going to improve our slope handling by implementing solutions to those issues. I'm not even sure I would call them issues. Depending on the type of game you're making, they may very well be just fine. But for my purposes and the direction that I'm taking this character controller, I guess we just call them unwanted features. Because, you know, it's not a bug, it's a feature. Sure, you never heard that one before. Anyway, enough talk, let's jump right into it, and let's look at the first feature that we're going to change. So if you remember from our last video, our max slope angle is 47.5 degrees. This slope in front of us is 50 degrees, so we should not be able to go up it. And if we're somehow just standing in the middle of the slope, I want our player to slide back down it no matter what. Currently though, if we go up the slope, and when we're up it, before we start sliding back down, if I let go of the movement keys, we'll just stay on the slope. That's not how I want this to work. Now if, for example, I press forwards, we'll actually go down the slope. And if I let go, we'll stop on the slope again. So that's not something I want to do. We're going to go ahead and change that now. We're in our Unity project now, right where we left off in our last video. In our project panel now, we want to go down to Scripts, Controllers, and we want to open up our Humanoid Land controller to edit it. Now that we're in our Humanoid Land controller script, we want to scroll down to our player slope function. And in our if statement, we're checking to see if we are on a slope. At the very bottom of it, we want to add a new if statement. I'm just going to go ahead and type it in here, and then we'll talk about it real quick. Okay, so this is very simple. All we're doing is checking to see if our ground slope angle is greater than our max slope angle. If it is, we're going to completely overwrite the y of our calculated player movement, and we're going to say it equals our current ground slope angle times negative 0.2f. And what that is doing is that is completely disregarding our previous calculation basically for the y value of it anyway, which is our player up and down. So it makes us go up and down slopes. And we're saying, no, we're not going up this slope, we're going to overwrite it, and we're going to make our gravity factor, our ground slope angle, times a negative 20%. And the reason why it's 20%, this can be whatever you need it to be. This should probably just be a variable, to be honest. But for now, I found that this number works okay, and we need it to be negative because we want to go down because we're on a slope that is too steep, so we want to go back down the slope. And of course, our calculated player movement is relative always to our player, so a negative y value is always our player's down. Okay, so make sure you save this, and then let's go back over to Unity and let's test it real quick. And now if I go up the slope and I let go of the move button, it just takes us right back down it no matter what. And that is exactly what we want to do. So that problem is fixed. I'll go ahead and move on to the next one. Next problem we're going to look at fixing is if we go up a slope, and if we go up at an angle, we'll actually go up faster at an angle than we will straight on. How slow we're going, but if we go an angle, we go a lot faster. That is not an intended effect, so we're going to change that. So stop the game, back to our editor. And once again, in our player slope function, if you remember in the last video, we added this line right here. And as a sort of cheesy way of setting a slope limit, we added this calculation, which is our relative slope angle divided by our max slope angle. But now that we have a quote-unquote proper way, or at least a little more proper way of setting a max slope angle that is separate, we can now go ahead and adjust this ratio to whatever we desire, because this right here is what is causing us to be able to run up slopes at an angle faster than what we would straight on. So we want to go ahead, I'm going to change this number for now to a 90. So what that'll do is that's going to change our ratio, and our movement speed reduction and or increase depending on whether we're going up or down the slope is still going to be linear, but it's going to be a lot less severe now since we basically just doubled the number. And I'm not going to go into the math and everything right now, but just take my word for it that pretty much going straight up a hill now will give you the same speed as going up it at a perfect 45. Okay, now I'm just going to cut over to the game and we're going to test that real quick. So I'm trying to keep this a shorter video for you. Okay, so what I've done real quick is I copied our 40-degree slope here and I made it much wider so that we have a good sized plane to run a test on. Over the inspector panel, I'm going to have our player selected so we can keep an eye on our Y velocity. That's going to be what's important here. And if I go straight up the slope now, you'll see our Y velocity tops out at about 6.16. And if I go at an angle now, it actually drops. So we are no longer going faster up the slope at an angle. The fastest way up the slope is to just go straight up the slope. And I am pretty happy with that for now. So moving right on to our next issue, the next issue that we're going to solve, and the last issue we're going to solve in this video, is if we go up against a slope that we cannot climb, our character will just jitter, he'll just bounce. Here, let me maximize this so you can get a closer look. Alright, if we go against a slope that's too steep, our character jitters, it bounces, that's not good. Same thing if it's a less severe angle, it's just going to jitter once it gets to the bottom here. See, it's less severe. And same with this one. Okay, so let's jump back over to our script and let's take a look at fixing that. Okay, let's review the code. At the risk of confusing you, I went ahead and I removed the knot in the ground slope angle check. So basically when we're checking to see if we're on an angle or not, I just removed that knot so that this is our new code here. The code that was previously here, obviously, I put under our else statement. To me, this just makes more sense. It reads easier. It's just good practice that when you're developing code, it reads easily, and that B, the most likely scenario, is listed first. Now, depending on your game, this may not be the most likely scenario, but this is the easiest way to read it. Okay, so moving right along, if we are on flat level ground, we're going to check C if our move is pressed. If a movement key is being pressed, then we're creating a ray cast called ray hit. And all of this is very similar to what we're doing for our ground check. We're creating a float, our ray height from ground, creating another float called ray calculated ray height, which is the center of our player, our rigid body position Y, minus our collider's Y extent, which is basically half of our player's height. So we're finding the bottom of our player, and then we're moving up just a little bit, which is our ray height from ground, and for that I'm using 1/10 of a meter or a unit, whatever you want to call it. So we're using all of this information to create a vector 3 that we're calling our ray origin, and all of this is just so we can send a ray cast into our direction of travel, and it's traveling 3/4 of a meter. If our ray cast hits something in our direction of travel, then we're going to get the angle of the thing that we hit. So we're assuming it's a slope, and we want to know the angle of it. If it is greater than our max slope angle, then we're going to significantly increase our gravity. Basically keep us on the ground. And this movement multiplier just so happens to be a pretty good number to use for this. You can use whatever number works for your character. For me, I just found that this worked pretty well for now. I'll probably end up changing this later. I was just being lazy when I did this. And then here we're just drawing a ray for debug purposes so we can make sure our ray cast is going where we want it to. And then next, if all of this comes back basically okay, or for whatever reason our calculated player movement Y is nothing, then like I said before, we just want to make sure that we're always having our gravity grounded being applied, and that's all that's doing. Otherwise, if we are on a slope, then it's just our slope calculation as before. So hopefully that makes some sense. I know this isn't probably ideal at all, it's just the first way I thought of to handle this issue, so really take it with a grain of salt, but if you need a solution, here's one right here. Like I said, it works very similar to what we've been using so far for our slopes and for our ground check. It's just basically using it for a different application. So with that, we're going to head back over to Unity and we'll test it out. Okay, and let's test our solution real quick. You can see if we run into the wall, we get one little hop from inertia, and then we stay grounded. So it works really well. And it was pretty simple to implement. Alright, if I unmaximize the window, and if you look up top in the scene view here, you'll see we now also get a green debug draw ray, as well as our red. And they're pretty much always going to point in the exact same direction. It's just the green's going to be lower because we're looking for slopes. They're more going to be around our feet. And you can see when we get up to it, see the red and green arrow actually pointing down because the gravity is being applied along with our forward direction. So again, working exactly as intended. Works great. So that's it for this video. I hope you found it helpful. Let me know in the comments below what you thought of it. I'm mixing things up in every video until I find something that works well, and your feedback is very, very helpful. Also, the more I hear from you, the more motivated I am to get these videos put together and uploaded. So if you find these helpful, be sure to like the video and don't forget to subscribe and tick the bell to be notified of new videos when I post them. So again, help me help you by liking and subscribing this video. In the next video, we'll be adding the ability for our character to jump. I'm not sure how much I'm going to squeeze into one video, but we will eventually be covering implementing a variable jump height, jump buffering, and coyote time. So I hope to see you in the next video, and as always, thanks for watching, and I appreciate you. If you're feeling generous, leave a comment down below. I want to read what you're thinking. Let me know if you have any questions or recommendations. I'd also appreciate it very much if you liked the video, and if you're feeling extra generous, it'd blow my mind if you subscribe to the channel. Being new to this and putting these videos together takes a lot of time and effort. Thank you for any and all participation and support. I look forward to continuing this in the next one. See ya.